Hey everyone! So, you've got your PyTop 4s for your school and now maybe you're wondering what's the best way to use them. In this video, we're going to show you a few things that we enjoy about using the PyTop 4. We're going to discuss the PyTop 4, the foundation plate and kit, and further. If you're completely new to the PyTop 4, then you may want to watch an unboxing video first, and there's a great one from Elektor in the link below. For this video, it's going to be useful if you have your PyTop 4 connected either directly to a screen and keyboard or connected to a laptop and accessed via VNC. If you don't know how to connect to your PyTop, check out our PyTop 4 connection video, which is also in a link below. You'll also need your foundation kit and plate, which comes with your PyTop 4. Finally, you'll need an internet connection and access to Further, PyTop's project-based learning management system for coding, robotics, and AI. Studies have shown that hands-on learning is significantly more effective, which is why we've created a physical, hands-on STEM product. Students make and program real things, and this physicality allows learning about design, manufacture, programming, science, and other skills such as collaboration and project management to be much easier, stuff that's just not possible to achieve with an entirely virtual approach. So, enter physical learning. But a problem that teachers have faced in the past with physical computing was fragility. Things do tend to be quite delicate and they do break easily. So wiring up circuits using an Arduino and a breadboard is a great thing to do. It's cheap and it's flexible, but in a class, setting it up can be fragile and it's easy to burn out components or simply wire things incorrectly. There is a lot going on here. Once there's a problem, it's often very hard to debug, and so for teachers this is a nightmare because students end up frustrated and the class suffers significant disruption. With PyTop 4, however, there's a lot of scope for making, but little chance of breaking. Our connectors are tough and all ports are clearly marked. This reduces the chance of wiring faults, and the sensors are magnetic, and they also come with Lego mounts, so kids can design and build housings for their challenges, like this one here. So they just pop on and off. It's really easy to build it into whatever you make. I made this in about 10 minutes. So all of this leads to less wasted time, less frustration, less issues for teachers, and more time for students to actually learn. It also enables more collaboration. It's easy to structure lessons so that some people are designing and making, whilst others are programming. A common question we're asked about the PyTop 4 is it a computer? And the answer is yes. The PyTop 4 is a full-featured computer running Raspbian, which is an operating system that is based on Linux. This means you can do all of the things you can expect to do on a normal computer. It comes with a powerful web browser, an Office suite, design and programming tools, and inside, the PyTop 4 has a 4GB Raspberry Pi, giving it great performance. Students can do all of their general day-to-day work, including remote learning. The key difference between a PyTop 4 and an ordinary laptop is that the PyTop 4 has a variety of interfaces, allowing it to connect to many different sensors, like an ultrasound sensor, and components, like an LED. This means that people can do physical computing and robotics projects with the PyTop 4 and a wide range of projects that can't be done with an ordinary computer. This has implications for your computer lab. Often in a lab, the computers are built into furniture and students have to access only the screen and the keyboard. And this is safe and secure and frees up desk space, but it limits utility and educational value. We want students to get hands-on with the PyTop 4. That's really the point. PyTop 4 is tough, it's small, and it doesn't take up too much space, and it's made for building, for connecting things to it, or for plugging it into things. The main implication is that the PyTop 4 works best if it's accessible when it's used in your class. Students should be able to just grab it, pass it, connect it easily while they work through coding challenges. In many schools, students have a Chromebook or other laptop that they do their work on, so how then do they work with the PyTop 4? Well, that's a great question, and the fit is actually really good. Students can work through challenges on Further, that's our project-based learning site that we'll show you shortly, and within Further, students are guided through design, making, and of course, writing code. What's really cool is that the code that they write on Further on their laptop can then be pushed to a PyTop 4 in the lab for execution remotely. What this means is that PyTop 4s can be passed around and configured with components and sensors for a challenge, and then the challenge can be run, results gathered, and then it can be passed again, and the experience is fun. It's easy to see port numbers, reduce wiring problems, plus it affords education about a wide variety of concepts such as networks and security and design. So now let's take a look at how PyTop products work and Further. The PyTop is the brain of the system. It includes a battery giving 5 to 6 hours of standalone use, and if you purchase the PyTop screen and keyboard, you can use your PyTop 4 as a powerful mobile computer. When you buy a PyTop 4, it includes the first project kit, called the Foundation Kit, and this kit includes the foundation plate and a range of components, and we'll be regularly releasing different kits. For example, the next kit that we're going to release is the Motors and Motion Kit, which allows you to build your own autonomous rover and a number of other projects for exploring robotics and AI. To help you work out what to do with your PyTop 4 and project kits, we've created Further, which is a standards-aligned project-based learning site where you'll find a range of challenges covering design, programming, physical computing, manufacture, and sharing. Our aim is to simplify teaching computer science, robotics, and AI. And for teachers, this means developing a robust yet flexible set of products that stand up to use in the classroom, coupled with excellent training and support. For parents wanting a product for their kids, it's about acing the right mix of fun, learning, and utility. Within Further, you'll find projects that people can do, and we call them challenges. The challenges generally involve assembling items in the foundation kit and then writing code to make the components do something fun and educational. We cover different aspects of coding, APIs, AI, physical building, 3D printing, and more, just a huge range of subjects. Our challenges use our learning approach of assemble, tinker, play, and share. So that's a taster, and we'll cover more about Further in more detail in another training video. So that's all from me for now, and all that's left to say is that we really want you to get the most from your PyTop. So if you need help, you can take a look at our forums on our website, or you can look at the PyTop knowledge base, or you can raise a ticket with our support team who'll be happy to help. And you can find links to all of those things in the description beneath the video. Okay, so as we say at PyTop, let's go and make the future.